All right, let's get started. Any homework questions over inverse trig functions? Yes, sir. 25? Sure. So let's look at 25. So number 25 says f of x is equal to x squared plus 2x cubed times cotangent inverse of x. Okay. Minus ln of 1 plus x squared. Minus ln 1 plus x squared. And it's asking us to just find the derivative. Okay. Very good. So we want to find the derivative of this function. Let's just take it one term at a time. First term, derivative of x squared is 2x. Second term, we have a product, right? We have 2x cubed times cotangent inverse of x. So we need to use the product rule. So the product rule tells us take the first one, leave it alone. So, and then multiply by the derivative of cotangent inverse of x. So what's the derivative of cotangent inverse of x?
Negative 1 over 1 plus x squared.
Yeah, very good. So it's times negative 1 over 1 plus x squared is the derivative of cotangent inverse of x. That's the first part of the product rule. So first times the derivative of the second plus the second cotangent inverse of x times the derivative of the first. The derivative of 2x cubed is 6x squared. Okay, so then that's the derivative of the second term. First times the derivative of the second plus the second times the derivative of the first. And then we need to take the derivative of negative ln of 1 over x squared. So the minus just hangs around. The derivative of ln of something is that thing goes on the bottom, 1 plus x squared. The derivative of that thing goes on the top, which in this case is 2x. And that's it. Sound good? Okay. Other questions? Yeah.
46.
46. I had a funny feeling someone might ask about 46. Okay. So let's take a look at 46. So we've got an angle of elevation problem. So small plane moving at 70 meters per second. Let's draw this picture. So calling this angle, that's theta. This height is 400 meters. And the plane, so we got a little airplane over here, is flying away at, it says 70 meters per second. Okay. Okay. What's the rate of change of the angle of elevation when the plane is 500 meters past the observer? Okay, so first of all, what I'm going to do is I'm going to call, they even do this, they say that let's call that distance that the plane is away from the observer, which is right here. So this is our observer. At this point, and x is the distance horizontally that the plane is away from the observer. So can we come up with a formula that gets all of these things involved. So 400 is over here, obviously. 400 is over here as well. And so I have this x, I have this theta, and I have this 400. Now, I don't want to get the 70 involved in my equation because 70 is a rate of change. In other words, 70 is a derivative. Now, what is changing? What does 70 say is changing? What's that?
Distance.
The distance. Yeah, what is representing distance in this picture? X, that's right. So X is changing. And what's it changing with respect to? Time, yeah. It's meters per second, right? So this even tells you what the rate of change is. It's the meters, a change in meters divided by a change in seconds. So the meters are measured, that's our X. Seconds, we don't have those on here, but that's time. So what we're really looking for is 70 meters per second is dx dt. Okay, where time is the thing that's changing. Okay, so what I want to do is get a formula that involves the theta, the x, and the 400. But does anybody have a good equation for that? Tangent. Yeah, because tangent involves the opposite side, the adjacent side, and the angle. So I could say that tangent of theta is equal to the opposite over the adjacent. So it's equal to 400 over x. Okay. So now there's a couple ways I can go here. Let's see what they ask for first. So they say, what's the rate of change of the angle of elevation d theta dt when the plane is 500 meters past the observer? Okay, so I can either use this formula, this is just fine. I could also solve for theta if I wanted to, and then theta would be tan inverse of 400 over x. Either way is fine. I can get the d theta dt either way. We're trying to do inverse trig functions here, right? So maybe let's just solve for theta. So I'll get theta equals tan inverse of 400 over x. And now I can find d theta dt. Let me just make sure. That's what they want again, one more time. Oh, they want d theta dx. Okay, that's fine. So d theta dx. So I want to take the derivative of theta with respect to x, and that would be, so what's the derivative of tan inverse of 400 over x? Well, first, before I say what's the derivative of tan inverse of 400 over x, what's just the derivative of tan inverse of x?
1 over 1 plus x squared.
Yeah, 1 over 1 plus x squared. So whatever's in here, I'm going to get 1 over 1 plus whatever is on the inside squared. So in this case, that's 400 over x squared. But then I need to multiply by the derivative of the inside function. So this is 400x to the minus 1. So the derivative of the inside function would be minus 400x to the minus 2. Okay, and of course I could rewrite that if I wanted to and maybe simplify this thing a little bit. But this is the derivative, and they want to know what is that derivative at a certain value of x. And in this case, that value of x is 500. Okay, if I wanted to simplify this a little bit first, let me see what I can do here. I've got a minus 400 on the top, right? So I've got minus 400 on top. This x is a x squared on the bottom. And if I multiplied the x squared through, I'd get an x squared here. And here I'd get an x squared over x squared. And it would just end up being plus 400 quantity squared. Everybody buy that? Okay, so now I just need to enter what is this d theta dx. If we evaluate it, x is equal to 500. So if I plug in 500 for x, I get minus 400 divided by 500 squared plus 400 squared. Okay, and then I plug that in. So what would I get out? Did somebody do this by any chance and get the answer? So obviously it's going to be a pretty small number, right? And it's going to be negative. And something I probably should ask myself is, does that make any sense that the change in theta is a negative number? So let's look at theta. Theta is this angle. And as this plane flies away, is this angle getting smaller or is it getting bigger? It's getting smaller. So you would expect the change in theta as x grows to be smaller. And that's what this is saying, that it's a negative number, but it's very, very small, right? So, and if you've ever seen like a plane flying away from you and it's way out in the distance, it actually hardly looks like it's moving at all, right? It does move, but it doesn't look like it's moving very fast. That's because that angle is decreasing at a very small rate. Okay, so this number does make some sense, even though I haven't simplified it yet.
I have negative 9.76 e to the negative 4.
Oh, yeah, that's really small. Yeah. So very small number. We'll go with that. So this is right, but of course, plug that into your calculator, get something. Okay, that's part A. Part B asks to graph that thing as a function of x and determine the point at which theta changes the most rapidly. Okay, so basically what they're saying is go back here to d theta dx, graph this thing as y equals this thing on your graphing calculator, and then see where is it that x is, that d theta dx is the maximal that it could be, the biggest change it could be. So that could be the biggest positive, the biggest negative, but it's going to be the biggest negative, right? Because in this case, this thing is always positive on the bottom. It's always negative on the top. So this thing is always having a negative change. So it's kind of saying, where is it the biggest negative that it could be? So just graph it and see where is it kind of the lowest on the graph using your calculator. Okay? Yes, sir.
When you have 400 over x, where does the x go?
Yes. Here?
Yes.
Yes. Okay, so this thing right here, let me rewrite this one more time. So this is 1 over 1 plus, I'll just write it this way, it's 400 squared over x squared, correct? Then you've got this piece, which is, I could write as a negative 400 on top, and on the bottom, it's x squared. So what I'm doing is I'm taking that x squared and I'm distributing it to both of those. So when I do this one, the 1 times x squared is my x squared. The 400 squared over x squared times x squared, the x squareds cancel. And I'm just left with my 400 squared. Yeah. Other questions? Yeah.
43.
43. Okay, 43 is asking for find the equation of a tangent line to the graph of that function at the given point. Okay, let's do that. So 43. we have f of x is equal to cosine inverse of x squared evaluated at 1 over root 2 pi over 3. Okay. So we want the equation of the tangent line at the point. Okay. So we need the derivative. And so we need to remember what is the derivative of cosine inverse of something. And what would that be?
Negative 1 over square root of x squared and negative x squared plus 1.
So negative 1 over square root of what goes here?
1 minus x squared.
Yeah, there you go. 1 minus x squared. But now, not quite, right? It's not 1 minus x squared. That's right if it's an x, correct? But we don't have an x, we have an x squared in here. So we get x squared squared. And then we need to multiply by the derivative of what's inside by the chain rule. So we get times an extra 2x. Okay, if I wanted to rewrite this, I could write it as negative 2x on top, and on the bottom, I get the square root of 1 minus x to the 4th. Okay, so here's my derivative, and I want to know what the equation of the tangent line is at this point. Well, I have a point. To get my line, I need the point and I need the slope. So I need to know what's the slope at that point. So I need to plug in the x value 1 over square root of 2. By the way, 1 over square root of 2 is the same as square root of 2 over 2, right? So I could plug that in. So I need to know what is f prime of square root 2 over 2, or 1 over the square root of 2, whichever way you want to plug it in. So I get negative 2 times square root 2 over 2 divided by the square root of 1 minus the square root of 2 over 2 quantity to the 4th, which is, on top the 2's cancel, and I just get minus root 2. And on the bottom, I get the square root of 1 minus. And then if I raise square root of 2 to the 4th, what is that? 4? Yeah, square root of 2 times square root of 2 is 2. And so square root of 2 to the 4th would be 4. And then on the bottom, I get 2 to the 4th. What's 2 to the 4th? 16, yeah. All right, we could probably do a little bit better than that. So on top, I've got a negative root 2. And on the bottom, I've got a square root of, this is 16 sixteenths minus 4 sixteenths is 12 over 16, which is negative root 2 on top. And on the bottom, I've got the square root of 12. Let's see, the square root of 12 is the same as 2 square root 3. Is that right? 2 square roots of 3 divided by the square root of 16, which is just 4. Okay, I'm just trying to get this as simple as I can before I have to use it. Which is, let's see, the 2 and the 4 can cancel and give me a 2 on the bottom here. So I get negative square root 2 divided by 1. Flip and multiply, and on top I'd get a 2. On the bottom I'd get a square root of 3. So I guess the best that I can do here is this is negative 2 root 2 over root 3. If you wanted to rationalize the denominator, I suppose that you could, and you get negative 2 times the square root of 6 over 3. Okay, so I did all that work to find the slope, right? And I have the point. So now that I know a point and I know the slope, then I can find the equation of the line using y minus y0 is equal to m times x minus x0. So I get y minus y0, which is pi over 3, is equal to m, which is negative 2 square root 6 over 3 times x minus x0, which is 1 over the square root of 2. Okay, and now just simplify. So I get that y minus pi over 3 is equal to negative 2 root 6 over 3 times x, and then positive times, I'm sorry, negative times negative is positive, and then I get 2 root 6 on top. On the bottom, I get 3 square root of 2. Okay, then I could add pi over 3 to both sides, and I get y equals negative 2 root 6 over 3 x plus, could I do any better here? Square root of 6 divided by square root of 2, I suppose, is square root 3. So I get 2 root 3 over 3 plus pi over 3. And that's probably as good as it gets. Any questions on this one before I move on?
In the beginning, it
Yes.
goes from negative 2x, and then when you plug in the value, it has negative 8. Why does that change?
Okay, so here I have negative 2x, and then what?
And then the next line, it says negative 8.
Oh, that's me. I crossed out the 2.
Oh, okay.
So this is a 2 here and a 2 here. So when I crossed out the 2's, I slashed them to look like an 8. Yeah. Other questions? Yeah.
33.
33? Okay. Let's take a look. 33, we're just trying to find the derivative. Okay. So we have, oh yeah. Okay. That is interesting. So 33, we have f of y is equal to cotangent inverse of 1 divided by y squared plus 1. Okay. So to take this derivative, first of all, we have cotangent inverse of something. And if it was cotangent inverse of just like a variable x, then we know that that's negative 1 over 1 plus x squared, right? But it's not an x, it's 1 over y squared plus 1. So we're going to have negative 1 over 1 plus whatever is here squared. In this case, it's 1 over y squared plus 1, quantity squared. Then we need to multiply that by the derivative of what's inside. But the derivative of what's inside is a quotient, so we should use the quotient rule. So we get the bottom, y squared plus 1, times the derivative of the top, which is 0, minus the top, which is 1, times the derivative of the bottom, which is 2y, divided by the bottom, y squared plus 1, quantity squared. Okay. That simplifies quite a bit, so we might as well do it. The 0 just takes out that whole piece. And now let's see what happens here if I multiply it together. So on top, I just have a minus 2y. And on bottom, I could multiply this through to this one, and I could multiply this through to this one. And nice things will happen with the second one, because I'll have a y squared plus 1 squared on top and a y squared plus 1 squared on the bottom. So they'll cancel. So when I multiply, I get a y squared plus 1 squared plus the y squared plus 1 squareds cancel, and I just get 1 squared or just 1. Okay, and I could multiply this out if I wanted to. I don't think it's really going to make the answer look that much better. So this is a good place to start. So this is f prime.
Is it positive 2y on top since it was negative 2y?
Oh yeah, thank you. This, I missed this negative. It's negative, negative, right? Yeah, thank you. That's a positive. Other questions? Yes.
41.
41. Okay. 41. Okay, this is another one where we want to find the equation of the tangent line. So we've got f of x is tan inverse of 2x. Okay, 41. We have f of x is tan inverse of 2x at the point 1/2 pi over 4. 1/2 pi. Okay. So the derivative, f prime of x, now we know the derivative of tan inverse of something is 1 over 1 plus that thing squared. So this is 1 over 1 plus whatever's inside, which is 2x squared, times the derivative of what's inside, which in this case is just 2. Okay, so this is our derivative. We have a point. I suppose if I wanted to, I could simplify this a little bit, not very much. This is 2 over 1 plus 4x squared. That's my derivative. So I want to know what is the slope at when x is 1/2. So if I plug in 1/2, I get f prime of 1/2 is equal to 2 over 1 plus 4 times 1/2 squared, which is 2 over 1 plus 4 times 1/2. 1/2 squared is a fourth times 4 is 1, right? And 1 plus 1 on the bottom is 2, so I just have 2 over 2 or 1. So my slope is 1. So I have a point, I have a slope. Now I can just use my point slope equation. Y minus y1, which is pi over 4, is equal to m, which is 1 in this case, times x minus x1, which is 1/2. Now just solve for y. So y minus 1, pi over 4 is equal to x minus 1/2. Now add pi over 4 to both sides, and I get y equals x minus 1/2 plus pi over 4. We're done. Sound good? Okay, I think I may stop there, and just the reason why I just don't want to do every single problem for you, leave some for you. But I think that should give you the general feel of these problems, and there are more online, of course, you can watch if you need to. I will give you a little bit of a warning of sorts. The next section is on what's called related rates. And I would say that related rates is one of the more difficult sections in the whole class. They're all story problems. It's kind of like like we had the plane problem. They're all sort of like that, except you're taking derivatives typically with respect maybe to time, maybe to something else, but you're looking at different rates of change in story problems. So my recommendation would be don't wait until like the night before to start that homework. You probably want to get started and watch those lectures as soon as you can, and then get into the homework as soon as you can, because it's going to take a little bit more thought than your average homework set. Now, right now I have that homework due on Friday, but I probably will give you till Monday. But what I'd like you to do is actually try some of the problems before Friday so that we actually have something to talk about on Friday. If nobody gets started until this weekend, you're not going to take really good advantage of having class on Friday. And you, believe me, you will want it. So I would say do at least half of the problems and try half of the problems before then. If not, try all of them before then. And then you will have questions, okay? And we can talk about some of those. But even if I tried to do all the problems in one day, I couldn't because they take a little bit longer. So get started early, get as much of it done as you can by class Friday. We'll do some questions on Friday. Then you'll have the weekend to kind of even do more work on that section. So just a fair warning, this one takes a little bit more time. Yeah.
So do we not have another homework over the weekend?
You do not. So that will be the one homework assignment. And then next week, the Monday, I'll probably do a little bit more on related rates. And then we'll have a review. And then that week, the Wednesday and Friday will be the exam.
Is it the same groups?
Same groups. Yeah, we'll do it exactly the same as last time. Yeah. Sound good to everybody? So yeah, recommendation, get started even today with related rates if you have time, and give it time. Problems like this, one thing I always say is like, sometimes I think of the answer to a problem while I'm sleeping. Like I try the problem and it's like, darn it, I can't get this thing. I don't know what to do. And then like in the middle of the night, I wake up and I'm like, wait, I know what to do. And sometimes I kind of feel like we don't give our brains long enough to think about a problem. They keep thinking about it even when you're not. So it's kind of like, give yourself some time. Yeah.
I know there's a currency exam up there on, so would you be willing to post that?
The key, yes. Let me, yeah, I would. I don't know if I have one, but I can make one. Yeah. Okay. Other than that, have a great day. I will see you on Friday, and we will talk about some related rates problems. Have a good day.